Welcome to my house. Welcome to the Structure Talk podcast, a production of Structure Tech Home Inspections. My name is Reuben Saltzman. I'm your host, alongside building science geek Tessa Murry. We help home inspectors up their game through education, and we help homeowners to be better stewards of their houses. We've been keeping it real on this podcast since 2019, and we are also the #1 home inspection podcast in the world, according to my mom. Welcome back to the Structure Talk podcast. Tessa, great to see you. But you know
Good
what?
to see you too.
I just saw you. We're doing a double header. We're doing
We
a double
are.
header. We don't do a whole
Part
lot
two.
of these, but
Part
it
two.
just worked out time wise. And we've got Michael from Standard Water coming on. Michael, correct me if I'm wrong. You are with Standard Water, right?
Yes, sir.
Okay.
So,
All right.
yeah, I'm the Foundation Repair Division Manager over here. Great title, great small company. Working with Steve has just been an absolute pleasure.
And what's your background, Michael? And what are you here to offer? I want to talk about Helical Piers.
Right. So a little bit of background about myself. I originally started with this industry back in Denver, Colorado, which is where I was born and raised. Worked out there in freezing clays and heaving soils. Very familiar with how ground reacts with the cold. And then from the Rocky Mountains, my wife and I moved to the southeast part of the country and lived out in Atlanta, Georgia for about 3.5 years. We were with a pretty good-sized outfit outside of Atlanta. That branch did about $65 million a year. We would do everything from push pier installs, helical pier installs, helical tieback installs, everything from, stabilizing a foundation wall from vertical movement to stabilizing a foundation wall from horizontal or lateral movement.
Okay. All right. And tell me, what is a helical pier all about?
So when we're coming through and stabilizing a home, we've got two options on how we're going to stabilize that home. We can either do what's called a push pier or a resistance pier or a helical pier. Now with a helical pier, you can imagine it almost as a giant corkscrew. So we'll come in with a mini excavator, or we can do it through a handheld. If we're coming in through the outside and stabilizing the wall from the outside of that home, what we'll do is we'll dig maybe a 2 foot by 2 foot by 2 foot hole, and that will go down all the way to the bottom of the foundation wall. We'll expose the footer of that foundation wall, and as y'all know, that footer will go out anywhere between 4 to 6 inches away from that foundation wall. What we'll do is we'll clip that footer in that maybe foot and a half space where we're going to be doing our pier. We'll drive our helical pier. When we drive those piers, they'll use the helix on those shafts. You can think of it almost like a DNA strand, how it kind of spirals around itself. It'll use those flights to drag itself into the ground and actually propel itself into a layer of soil that's going to be dense enough to support the home. We call that a load-bearing strata. So how we know we've hit a load-bearing strata is when we go into a home for the inspection, we'll take the dimensions of the home itself. We'll find out what kind of foundation wall is in place when the home was built, and we'll work with our engineer to develop a plan. And our engineer will tell us, hey, we need to hit, X amount of PSI to support this structure. So we'll keep driving those piers in until we hit that, amount of PSI called out by the engineer. Then we can say 100% this wall is going to be stabilized for the lifetime of the structure. When we come in, I'm not doing anything that's going to be a Band-Aid for the home. We're doing things that are going to last the lifetime of that structure. The engineer is also going to be who calls out the spacing on those piers. Typically, you can kind of do a rule of thumb for a 2-bedroom structure or a 2-floor structure. Most of those piers are going to be anywhere between 4 to 6 feet apart from one another.
Okay. All right. And now let me ask you, if you got what I'm picturing is a big long steel tube or a steel rod. It's a tube, right?
Yep.
All right, big long steel tube, and you got basically a screw on the end of it, this big wide screw, kind of like a ice auger or something like that. And how long are these sections of pipe?
So each one of these sections are anywhere between 3 and 5 feet.
Okay, so you go down. How far down do you got to go until you hit the required PSI? I mean, I know everyone's different, but I mean, what's a range? Is it going to be 10 feet, 30 feet? What are you looking at?
Yeah, typically what we're seeing here in the Minnesota area is we'll be going down anywhere between 15 and 45 feet.
Okay, and so you're
Whoa.
taking a 5 foot rod. You go 5 feet down, and then what do you do? Do you weld on the next one? How does that work?
Yeah, so with these pipes, it's very similar to like a sewage piping or anything else where they have a male and a female end. So they'll have a bell end that will slide onto the end of the pier that you've just driven. We'll use half-inch lag nuts to go through that last pier and the new coupler on it, and that's what actually secures those lengths of pipe together.
Okay, okay, got it. And
Is-
those,
Yep.
Oh, go ahead. Finish your thought, Reuben. Sorry to interrupt.
well, I'm just thinking like, okay, you got a lag screw sticking out. That's not going to really interfere with anything. It's not so much sticking out that it's going to screw it up, right?
Oh, no, no. So it'll just be coming out, 3/4 of an inch to an inch on the other side, just enough to get a bolt on there and tighten everything together so we know it's never going to move in the future.
Okay,
We really don't need a whole lot of length on the outside of that pipe.
okay, got it.
So I was going to ask, I'm not too familiar with this helical pier, foundation stabilization system. Is this a newer technology or has it been around for a while?
So helical piers have been around for quite a while, actually. So quite a few decades. I know there's been options in the past. Some people have wanted to come in and do like new concrete columns, where they'll actually take, pills of precast concrete and use a hydraulic ram to just shove those into the ground. The issue with those is they're super hard to maintain, and concrete just doesn't last the same way that steel does.
Hmm.
Um, so instead of doing that, I've always found that the helical piers have been the easier install, a lot less invasive, and a lot easier to warranty for the lifetime of the structure.
Huh.
Okay.
And are there certain types of like cracks or foundation issues that are perfect for a helical pier solution?
Yeah, so what's really nice about a helical pier is we don't need, in the case of a resistance pier, we're actually using the weight of the home to drive that steel into the ground. With a helical pier, it drives itself on its own volition. So we can come in and say you've got a 3-season porch or a 4-season patio that is starting to settle. Maybe it's on some old 6x6 columns on a 3-foot mono or sonotube, right? The nice thing about a helical pier is we can come in, we can drive those piers down to a load bearing strata. We can pour a new concrete pad on top of those with a rebar cage in there. And then we can lift up and then reset those patios. That's an absolutely perfect situation for a helical pier. Also say you've got a garage box that might only be 4 or 5 courses a block down, but that whole side of the garage is starting to fall out. Helical piers are a
Hmm.
perfect application in something like that as well.
What about like a front porch on an 1900 built house in North Minneapolis that never
Yep.
had proper footings and is starting to fall off the house? Can you do helical piers for something like that too?
That's also another great situation for helical piers. Instances like that, what we'll do is we work with a company called Foam Tech. They are a poly level company. As we go through and raise those front patios, what we'll do is we'll create a void underneath that patio. So what we want to do is fill in that void with, a poly foam, something that's going to address the poorly compacted back soil, as well as filling in that void.
Okay. Got it. And if you're going to come in and you're going to jack up someone's front porch or at least stabilize it on like so many of these houses we see in Minneapolis and St. Paul, what type of cost is someone looking at for something like that? What's a price range?
Yeah. So what we do is we do about $2,000 a pier. That's for a standard install going down to a 4-foot footing. Um, and we'll do, depending on the front patio, depending on how many we need, we'll either do one or two. If they just have a little 4x4 stoop that comes off the front and that stoop is starting to fall away, We might just do one on one side if the other side hasn't settled, just to make sure that we can stabilize that, fill that with the polyfoam. To give a complete solution, we always recommend we hit both sides of that.
Okay.
So for something like that, you're looking anywhere between 4 and 8,000, just depending on how wide that patio is.
Okay. And then what about for decks? Do you guys ever do helical piers to support decks?
Yeah, all the time. If you've got a back deck that, the wood is still good and you don't want to completely remove and replace everything, we'll come in and we'll temporarily support that back deck. We'll do new construction helical piers in that area with new footers, rebar cages, all engineered approved. And then we'll set in a new 6x6 wood support there, sitting on, a nice metallic, footer for that going into that concrete.
Yeah.
Wow.
And is the cost the same? Is it like about $2,000 per pier? Or
Yeah, so with something like that, since we are doing the additional labor of temporarily supporting the structure, we're also replacing that wood support and doing that new footing in that area. Those run about 2,600 a piece.
Okay.
Okay.
And I know that in some cases it really is the best option. Let's say you have really nasty soils, like where I'm at in Maple Grove, we've got very expansive clay soil. People have decks that heave all the time, all kinds of problems with frost heave, and people are always trying to fight it. And I know one of the things that's basically going to guarantee that you never have that problem is putting in helical piers, and it's just something where you can have peace of mind. You never need to worry about it. My last house, not the one I'm in now, but previous house, I had this huge stamped concrete patio in back, and there was no deck. And I was thinking about putting a deck in, and the footings would have had to go basically right in the middle of this stamped concrete patio. And to do a footing through that for a traditional footing, you'd have to cut out a huge section of that concrete and then dig your hole for the concrete footing. But if you're doing a helical pier, my understanding is you can cut a pretty small hole in that concrete, so it's way less intrusive. Am I right in that? And can you
Yeah,
talk about
so
that a little?
Yeah, so just depending on the amount of weight that we're trying to support above that pier would determine the diameter of that new footer that we have to pour for you, and that would be specified by our engineer. But if we're going in with like a pretty light structure that's going to be on top of it, say just a regular deck, more often than not, we're allowed to cut just a 1 foot by 1 foot square in our the flights for the helix. So think about them almost as like a screw blade.
Yep.
Those are only 10 inches in diameter. So we don't have to do anything more than a 1 by 1 cut into that concrete.
Okay. All right. Really cool. And then if you're just doing the piers themselves, you're not messing around with the posts, the wood posts, or any of that, and you're not shoring up the deck. What would someone's cost for something like that be?
Yeah, so if we're just coming in, say they've got, like a nice column that sits on a good footing and that footing's just starting to settle, right? And we don't have to go in, we don't have to pour a new footing in that area, don't have to replace that column. Depending on the size, if they use like a, 1 foot wide sono tube, our brackets for our helical piers are only 10 inches across. So we can go in and we can set our brackets underneath the existing sono tube and be able to support the bottom of that footer. In a situation like that, then we're just looking at our regular $2,000 a pier.
Okay. Okay. Got it. Got it.
No, like a helical pier wouldn't be a solution for a foundation wall that's significantly like bowing in or has a lot of horizontal cracks. Is that
Right.
correct?
Yeah.
Okay, so you've
So
got a different solution for that.
Yeah. So when we see lateral movement into the home, there's always going to be a few signs that really say right away, hey, this house is probably just moving into the inside. That's going to be when you walk into the basement. I'm sure y'all have seen this countless amounts of times. You walk into the basement, you can see a long horizontal crack about halfway to 3/4 of the way up the wall, right?
Yep.
Mhm.
So, so that's going to be what I've always been told is stage 1 wall failure. That large horizontal crack. When we
Mm-hmm.
start getting into stage 2 wall failure, what we're going to start seeing are stair-stepping cracks coming up from either the corners or the windows to match that horizontal. Those cracks are alleviating the additional pressure as that wall has continued to move into the home. At stage 3, what we're going to see is either tipping or shearing at the top or bottom of that wall. So now that wall is starting to be carried laterally into that home. At stage 4, it's going to be a complete remove and replace. That wall is now on your basement floor, and you are going to be seeing me or one of my friends every day for a very long time.
So what do you do to stabilize stage 1 or stage 2?
Yeah, so in stage 1, stage 2, as long as we're under 2 inches of lateral movement into the home, I recommend we do what's called a Fortress carbon fiber strap. The reason I like Fortress so much is that Fortress pre-tensiles all of their straps. You know, there's a couple of companies here that use a material from a company called Rhino. Rhino makes, it's solid carbon fiber. They allow homeowners to install it themselves. The issue is they give you a loose roll of carbon fiber, and then they give you an epoxy. So then you go on, you can just kind of slap it onto the wall, you cover it in your epoxy, call it a day. But none of that carbon fiber has already been stretched. None of that's holding any tension to it. Um, Fortress already pre-tensiles all of their carbon straps. So what we'll do is it's a 3-part system. We'll come in, we'll remove a 8-inch by 8-inch section of the concrete down at the base of the wall. If our drain tile is already in there, what we'll do is we'll cut out that section, we'll remove that section of our drain tile at no cost to the homeowner, and replace that section when we're done. Then what we'll do is we'll apply a 2-part epoxy. Well, we'll condition the wall first. We'll come in with a big, 7-inch grinding blade. We'll grind down any of the dry lock, any of the paint, and open up the pores in those actual blocks. Then we'll come in with a 2-part of epoxy, and we'll coat that wall in that area with that 2-part epoxy. When we're done with that, we'll put our strap on. And the nice thing that I really like about Fortress is we use what's called Mylar. It's just a real thin plastic, but you'll run that plastic over it and it creates a vacuum inside of that carbon fiber strap that will actually pull that epoxy all the way through and impregnate that strap all the way through.
Oh, cool.
Yeah, it's super neat. I really, really like this material. At the top of the wall, we'll do a necktie is what Fortress calls them. And that's going to be a bracket that adheres either onto the sill plate, the rim band, or the floor joist, just depending on what the best install in that particular instance is going to be. And that's going to be what translates any of the pressure that comes in from the top of that wall onto the rim band. And then we'll actually use the floor joist or the house itself to counteract that pressure of the lateral movement into the home.
Wow.
Okay. All right.
Wow. Do you ever have to adjust those straps at any point in time?
So we've been doing these straps for quite a few years now, and we have never had to go back to adjust the straps. That's one of
Okay.
the great things is that those are a rigid install.
Okay.
When we do get outside of that 2 inches of movement, we've got 2 other options that we can do. We can either do what's called a power brace. It's going to be a 4-inch piece of galvanized steel that'll run from the footer of the wall on the inside of that foundation wall up to the top of that foundation wall into the floor joist. We'll adhere or install a bracket onto the floor joist itself, and we'll put a big tension screw in that bracket. So you can imagine, your foundation wall is sitting straight, your 4-inch I-beam is sitting flush against that foundation wall.
Yep.
And then at the top of that is where that tension screw is. So we can come in over time if we ever do have to add pressure to that, and we can add pressure to the top of that brace and push that wall back. That's never going to be a guarantee. We can never guarantee that we'll get any lateral movement back onto a wall without doing a full excavation on the outside.
Yeah, it makes perfect sense. Sure.
Yeah. So we
And then
can.
for the braces or for the straps, how many of those do you need to do? I mean, you do one every 4 feet, every 6 feet. What does that look like?
Yeah, so we'll typically do them every 4 feet for the carbon fiber straps, and then we have to use an engineer for the wall anchors. So we'll allow the engineer to decide what the spacing is going to be on those wall anchors or those power braces there.
Okay, and what does the cost look like for these two systems?
For these two systems, we run $1,000 a piece. They're both very
Okay.
similar on their install, so we're able to keep them at the same price.
Okay. Well, it's good to hear that. I mean, I'm just thinking about some typical old Rambler where you've got a foundation wall coming in on one side, on the long side, on the back of the house. It typically is bunch of soil pressure, poor grading. You got this long horizontal crack, and people freak out about it. But just hearing you say, like, look, if we focus on the worst areas, you need one strap every 4 feet, and maybe you're putting in 5 straps or $1,000 each. This is a $5,000 thing to stabilize that foundation wall. It's not that scary. It's not like this is the end of the world. I
Yeah.
mean, it's good to
It,
hear that it's a fairly affordable solution.
yeah, and they're by no means alone. When a homeowner feels that this might be a scary thing for them, I'm here to let you know that there's guaranteed someone else in your neighborhood that is going through the exact same thing they are. And there's knowledge. Huh? I'm sorry.
I was just gonna say I saw two houses in Red Wing this summer have to dig up portions of their foundation and rebuild them. So
Yes.
I don't know, does this method work for like a stack stone foundation too, or just concrete block and poured concrete?
Yeah, so the power braces would work for a stack stone foundation. The wall anchors will also, or earth plates will also work for a stack stone. Carbon straps will not work for a stack stone.
Okay.
Okay.
Yeah, I couldn't imagine how it would work with stacked stone
No.
having such an uneven surface.
Right. So, and then that gets me to the third option for repair that we have for lateral movement, and those are going to be earth plates. So, what we'll do is once again, either at a 4 to 5 foot spacing, and this is going to be in the event that, the homeowner doesn't want a 4 inch beam on the inside of their foundation wall. Say their framework is only, a 2x4 but flat against the wall, and we don't have that 4 inches of space in that area. If the homeowner wants to save a little bit on that room, what we can do are these earth plates. So what we'll do is 14 feet away from the foundation wall, we'll dig a trench on the outside of the house. That trench will be anywhere between 4 and 6 feet deep, and we'll run a 3/4 inch steel rod and it's going to be an all thread rod. We'll run that from the inside of the foundation wall out to where our trench is. On either side of that wall, we'll be putting on a big, galvanized steel plate. You can think of it almost as a giant sandwich, and we'll put two giant screws on either end of that rod, and we'll tighten everything together. And we're actually using the weight of the soil that at one point in time was causing all these problems to actually hold the weight of that wall again.
Wow. So that's I've seen that before, that repair method, but I guess that doesn't work in all situations. Like if you've got a house that's on a really tight lot line and you don't have potentially 14 feet of yard space you can go into, then that may not be a good option for you.
Right. Yeah,
Okay.
and once again, that's why we do offer the power braces. And
Yeah.
then we have to have that rough conversation with the homeowner that, maybe your framework has to change a little bit, because this is the environment that we're working in with your home.
Sure,
Yeah. Yeah.
sure. And what
And are
what do
those
those
more
things cost?
expensive? Yeah.
Oh,
We're on the same
same question.
wavelength.
Yeah, so with the additional labor on there, we do have to run those at 1450.
Okay. All
Okay.
right. Got it. And how many feet? I mean, how often do you need them? Every 4 feet, 6 feet, or engineer designed?
Engineered design on those.
Okay. Okay.
Mm-hmm.
Got it.
Because it's also based off of the foundation wall, whether or not we use a 7 inch wide C channel instead of just the regular plates. And I'm going to let my engineer tell me, what he would recommend in that situation.
Okay. Got it.
So I really liked hearing you kind of classify, like, what did you say? Stage one failure, stage two failure.
Yeah.
And, you know, if it's just a horizontal crack, it's stage 1. If it's a horizontal crack with the stair steps at the corners to alleviate pressure, it's a stage 2. At what point would you say you should do something to stabilize your foundation? Is there a black and white, like a hard line in the sand where when you see this certain crack or this amount of bowing that it does need attention?
Right. So I always come from the school of thought that says there's no such thing as a half-failed wall. If we've come in, say the homeowner did dry lock paint or painted these walls 3 years ago, and now we're seeing cracks in there again. Anything that tells us that that wall is actively failing is
Hmm.
something that draws that black and white.
Okay.
If we know that wall is actively moving, it is something that is never going to get better and has to be stabilized.
Okay. I
Okay.
think that's a good tip. Yeah. So if you're concerned about your foundation, you could tell a homeowner to maybe keep an eye on those cracks. And if they continue to move or get bigger, that's when they need to address it.
Yeah. Yeah. And a lot of times, especially for vertical movement on a home, engineers will tell you that it's pretty standard to see a little bit of settlement in a home, 10, 15 years after it's been built. That original settlement might cause some small hairline cracks on the outside mortar in your cement block. Being
Mhm.
able to put a time frame on any of those cracks really gives us a huge leg up on whether or not this is something that we need to be active on now before it causes a bigger problem.
Yes.
You know,
Yes.
Yeah.
So true.
yeah,
Take the take it in context, I guess is what you're saying. Did it just
yeah,
show up? Did it show up overnight or has it been there for 15 years? Just slow, kind of normal settlement.
Yep.
right. And I mean, y'all see it all the time. We go into homes that were built 130 years ago. Before I
Mhm.
tell a homeowner, hey, you need to spend, a good sized ticket on this repair, I need to make sure that I'm being as honest as I can, and setting a time frame is a great way to make sure that, the contractor that comes to your house is being honest.
Sure. Yep. That's
Mhm.
good. And well, and you guys have the same approach when it comes to basement waterproofing. It's like you're not quoting repairs on every single job. Steve on the last show, he was just saying how they'll quote repairs 8 out of 10 times. The other 2 times out of 10, they're not telling people to fix anything because they got other issues they need to deal with. They're not trying to put drain tile in every single house. And so I
Mhm.
appreciate that you guys have the same approach with foundation repairs. You're not just coming out to sell
Mhm.
somebody stuff they don't need every time. And that's why we have no problem referring you guys as company.
Yeah.
Yeah.
And I threw it out at the end of the last show. I'll throw it out again. The name of the company is Standard Water, and that's their website, standardwater.com. Any other thoughts that we could give our listeners before we wrap up, Michael?
Yeah. So we actually never talked about push piers.
Oh, push,
Oh,
yeah, push
Yeah.
piers. We talked about helical pier. What's a push pier?
yeah.
So a push pier is also called a resistance pier. So what we'll do is very similar to a helical. We'll dig our pit from the outside. We'll expose that footer. We'll condition that footer. What we do then is we set our 10 by 10 bracket underneath that footer, and we start feeding steel through our bracket. And we actually use that bracket sitting underneath the foundation wall to provide resistance and to hold that pier or that bracket in place while we use a 4-ton hydraulic ram to shove steel into the ground until we hit that load bearing strata.
Oh,
It's a
cool.
it's a beautiful way to install piers. Very non-invasive for the home. You don't have mini excavators sitting out in your yard, and it's a very efficient install. The nice thing about using a resistance pier is if we are trying to achieve lift, what we're doing as we're walking our way down there is putting thousands of pounds of pressure back onto that house, back in the direction it came.
Hmm.
So when we come through and we install, say we have, 4 or 5 push piers that we're doing around the corner of a house that's settled a couple of inches. When we have those piers installed, what we'll do is we'll install lifting stations on top of those piers, and we can lift all 5 piers in unison to get that entire part of the structure, attempt to get it back. It's always taken a few decades or years for a house to get where it's at, and I can't in
Mm.
all honesty say that every time we're going to get lift. But what I can tell you is we've got a solid group of guys here, and with the knowledge that we have, we'll give it everything we got every time.
That's great. That's great. And what's the cost difference? What do those things look like?
So we actually run just a standard 2,000 a pier. Since we are given the lifetime warranties on everything, and it's all high grade materials, we have to, keep at that price point.
Okay.
The nice thing about, I guess, yeah. Well, like I said, the nice thing about those push piers is it gives us the attempt to lift. So now this is what I would caveat that with the homeowner, if they have gone ahead and replaced windows and doors, since they've noticed that old doors and windows have started to stick, those windows and doors have now been framed to framework that has settled. So in situations like that, we need to have an honest conversation with the homeowner as far as what's important to them. Is stabilization important to you, or do you want a level foundation? Because there has been times where I've gone in and lifted a foundation 4 inches, and with the homeowner's approval, broken every window on that side of his home.
Oh my
Wow.
goodness.
Oh.
Yeah, I wouldn't like that.
Yeah. So that is a conversation that we need to have, because if those windows were set in a framework that was 4 inches down, a lot of times they won't let us lift back to normal. So, and then what I'll say after that was when we're all done, everything's backfilled, you can't see our piers anymore. What we do is we install benchmarks onto the home. Since we give lifetime of structure warranties, we'll set up a transit laser on the outside of that house, and on a level plane, we'll install rivets at 5 to 6 foot spacing in that cement wall, or in the siding, or if we can't get down to the first course of block for the foundation wall, we'll install them there. That way we can come back 20, 30 years down the line, and if those rivets aren't on a level plane anymore, then we know, hey, this is a warranty issue, something's shifted. We'll come back and we'll repressurize those piers. What I will say though is, every benchmark I've ever set has always stayed there whenever I've gone back. These solutions are very solid.
That's awesome.
Yeah.
Cool.
Well, very, very educational and helpful. Thank you so much, Michael, for coming on the show and sharing all of your wisdom and experience with us on foundations.
Yeah, appreciate it. This is good. Good to hear that there's affordable solutions for people out there.
Yeah.
But, and for the listeners, if you've got any questions, feel free to reach out to us. Our email is podcast@structuretech.com. And if you want to reach out to Standard Water, we will have their contact information in the show notes. So I am Reuben Saltzman for Tessa Murry, signing off. Thanks for joining us. Take care.
Thanks for listening.